Alright, welcome back, llamas. This is topic 11, block 3. This is part 2 video. We're starting on question 3 on page 361. To answer problem 3 through 6, we have to look at problem number 1. So flip and take a look at problem number 1. Flip and take a look at problem number 1. How are you flipping back when you... Yes, okay. All right. So, looking at problem 1, the first question, number 3, asks, the simulation produces an average number of rolls per trial of what? So, looking at number 1, what was the average number of rolls we found? 14.9. So, write that for number 3. Number 4 asks, based on this finding, you could expect to buy blank boxes of cereal before you found all 6 puzzle pieces. So how many boxes should I buy? 15, because it rounds up. Okay, number 5 says theoretically, the least number of boxes you would need to buy would be what? Theoretically, what is the least amount of boxes I could buy to have all 6 puzzle pieces? 6. There is a chance I could win the prize. Then true and false. Theoretically, you could purchase 50 boxes and not find all 6 puzzle pieces. True. Okay, so that was number 6. So, number 7, so the cereal company was having a lot of people win the grand prize of finding all 6 puzzle pieces. So, they said we need to make this a little harder. So, they said for the next 1,000 cereal boxes that they are going to have puzzle piece 1 through 5 have equal likelihood of being picked, but puzzle piece 5 and 6 they were going to make harder to pick. They're only going to make half as many of those puzzle pieces. So those 2 would be harder to find. So, let me go to the slide here. So if I need a grand total of how many cereal boxes did they say? They're making 1,000 cereal boxes. Okay, 1, 2, 3, 4, 5, and 6. 1 through 4 need to have equal chances of winning. 5 and 6 have to have half as many chances of winning as 1 through 4 have. But I need all of them to add up to how many cereal boxes? 1,000. Can anybody think of the magic numbers that would add up to 1,000 where the 5 and 6 is half of what one of these numbers is? Someone says 200 on 1 through 4. Okay, she said 200 here, 200 here, 200 here, 200 here. How much is that?
400. No, that's 800.
800. And then what's half of 200? 100. 100. How much is that? 200. Does those 2 add up to 1,000?
Yes.
Okay, so that's how many of each puzzle piece they're planning to make. So I'm going to go back to my chart and fill it in for the number of created. So how many puzzle pieces of piece 1 are they making? 200. How many of piece 2? 200. How many of piece 3?
200.
200. How many of piece 4?
200.
200. How many of piece 5?
100.
100. And piece 6?
100.
100. Okay. So that's how many puzzle pieces they're creating. Now, we need to look at the ratio of number of pieces to total number of boxes. Well, puzzle piece 1, how many pieces did it have? 200. 2, how many total pieces? 1,000. Can that ratio simplify?
Yes, 1/5.
It can simplify to 2/10, but it can simplify more to what? 1 to 5. So the ratio of pieces to total boxes would be 1 to 5. What about puzzle piece 2? Do I have to do different math or is it the same? It's the same. Okay, what is the ratio for puzzle piece 3? 1 to 5. Number 4? 1 to 5. What about number 5? It has to be half of what this is. No. Shh. So how many total pieces did 5 have? 100. The total was 1,000. That simplifies to 1 to 10. Isn't 1/10 half of 1/5? Yes. So 1 to 5, 1 to 10, and 1 to 10 for 6. Okay. Then it's asking for the theoretical probability. So they're asking that as a percent. So I need 1/5 as a percent. Anybody know what 1/5 is as a percent? 20%. So it's 20% for puzzle piece 1. 20% for puzzle piece 2. What about 3?
20%.
4?
20%.
5?
10%.
It's half of that, so it's 10%, and 6 is
10%.
10%. Alrighty. So they established, I'm on number 8 now. They established that a dice is no longer going to work for me. Because does each side represent the same now? No. A dice, every side represents the same. There's no way of me rigging this. So a dice no longer works. So I need to think of some other probability device, mathematical device that I could use. Well, would a penny work?
No.
Because I need 6 sections, right? What could I use?
A spinner.
Well, given the hint that they give us on number 8, I'm probably going to have a spinner. Well, how many sections needs to be in the spinner?
6.
6. Are they all going to be the same size?
No.
No. So you said I need 6 sections. Okay. And they're not all going to be the same size. So they have measured these based on fractions. Well, what fractional size does 4 of my sections need to be?
20%.
Which fraction? What is 20% as a fraction? You have it written in your chart. 1/5. So right now they're at 1/6. So is 1/5 larger or smaller? Larger. 1/5 is larger. So I need 4 of the sections to be 1/5. That's 3, 4. What about these last 2 sections?
They need to be 1/10.
How are they going to compare to these other
They can't
4?
because they're gonna be smaller, so
How are they going to compare?
They're going to be
They're gonna be
half.
How much smaller?
Half.
Half. So it's going to be 1/10 is what we found. So we need to sketch us a spinner that looks like this on your spinner for number 8. Doesn't have to be perfect, something similar. And we said we couldn't use a dice anymore. We can't use a coin. I need something that represents 1 through 4 puzzle piece to be twice as likely as 5 through 6. Can you think of a histogram's a graph? A graph is not a problem. That is just a form of writing your answers down. It's an object. What objects could I use other than this spinner to create this probability? We said a penny only has 2 sides, right? So it's not going to work. This 6 sides is fine, but it's not equal anymore. The spinner works. What's some other mathematical devices? Bonus point opportunity.
For how many sides do you need?
I don't know.
Oh, 6.
Wait, what's the question?
Number 9. What mathematical device could I use other than the spinner I just created?
A
dice. She said
You
not
can't use a dice.
or a spinner. Another one.
I don't know, John. I don't know.
She said it doesn't.
You can use
It's not something you draw. It's an object.
a penny.
She just said not
A
a penny.
penny has 2 sides.
She said
A penny has 2 sides.
So it can't be a spinner, not a dice.
Calculator is just a mathematical tool.
It could be like. I don't know. A number one can't be.
That is not, it's not a graph. It's a physical thing.
Like, is it
a normal everyday?
So it's an actual thing.
Okay,
Oh, you're kidding.
okay, let's take a look at this. Watch. If I put one of each card into the hat, that is mimicking the dice that I have right now. Right? Because it's representing one of each side. And we already said that doesn't work. So what do I need to do to have card 1 through 4 be double as likely to happen than 5 and 6?
You need to
Put what? There needs to be 2 of those cards in the hat. Now I have a total of how many cards in the hat? I put all 6, then I added 4 more, I had 10. So there's 10 cards in the hat, double 1 through 4. That is a probability scenario I could use. Someone last hour came up with maybe a 10-sided dice. And they had 2 sides that said 1, 2 sides that said 2. How many sides would say 5? 1. How many sides would say 6? 1. You can make it whatever side you want. So for number 9, we're going to write playing cards. So we know that those are other options. And that's it for today. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell. Comment if you need to. And peace out, llamas.
Bye.